talk about what's due a little bit. So the course agreement form, that mandatory course agreement form on Blackboard, that was due last night by midnight. So if you didn't do it, you can still do it and get partial credit. As well as the orientation to Connect Learn Smart, that's that one with the 2 videos where you just watch them and click yes, I watched them. That was due yesterday as well. So coming up on Wednesday, because assignments are always due Sunday or Wednesday. So Wednesday, the questions, the homework questions from chapter 1A. So it's on significant figures, scientific notation, and that's basically about it. So doing calculations with significant figures as well. Also the discussion. So most people have already done the discussion and done it twice, but you can still, you have till Wednesday to get your 2 posts or replies up on the discussion board. And that is it for what's due Wednesday. So due to the discussion board, I noticed there were a lot of questions and confusions with scientific notation in both my sections when it came to negative numbers. And I realized I never did a negative number one on the board. So I wanted to make sure to do that. We did this number when we just counted the significant figures, but we didn't put it in scientific notation. So if you have a number with a negative sign, just pretend the negative sign's not there. Same rules apply. So ignore the negative sign, make sure to include the negative sign in your final answer, but don't change any process of what you're doing. So let's start by just counting the significant figures, because we need to keep them in the scientific notation form as well. So to count them, remember, non-zero numbers always count. You can't start counting until you get to your first non-zero number. So we're going to count at the 2. Okay, so we know the 9 counts and the 7 counts. And as you already said, you know that this 0 counts. Okay, so the reason this 0 counts is because there's a decimal point and we already started counting. Okay, so you need to have started counting for any zeros after the decimal to count. All right, so we have a total of 4. So if I'm going to put this in scientific notation, I'm just going to ignore that negative sign and follow the rules that we talked about last class. So to do that, we want to make sure there is one number, one non-zero number, to the left of the decimal. So where is our new decimal point going to go? Between what 2 numbers? Go ahead. Yeah, I started a minute or 2 early. We're just doing a review with scientific notation anyway.
Okay.
So where am I going to want my decimal when I have that scientific notation? Between what 2 numbers?
Are you asking the question? Mm-hmm. Oh, which one? One number on the left-hand side?
Right, you want just 1 to the left of the decimal, so it's going to go between the 2 and the 9. Okay, so what I'm going to see when I write this out is I'm going to have 2.970. Remember, I'm keeping that 0 because I said it was significant over here, so I need to keep it. Now, to figure out what the exponent is going to be, that's how many times we move the decimal. So I'm going to start at my original decimal, and to get it between the 2 and the 9, I'm just moving it once. Okay, so it's going to be a 1. Now this is the part that confused people because of that negative sign. All right, is this a negative 1? Is it a positive 1? Okay, when you're doing negative numbers, just pretend the negative sign isn't there and put it in scientific notation as if it were positive. Okay, so if that negative sign's not there, this would have to be a positive 1 exponent, because I moved the decimal to the left, so that's one way of remembering it, or the original numbers greater than 1. I think that's where people got confused. They saw the negative sign and they're going, oh, it's negative 29, that's less than 1, it must be a negative exponent. No, you're looking at the number without the charge. Okay, if this number was greater than 1, it's going to stay a positive exponent. Now all I have to do to finish that is just bring my negative sign over. All right, so let's try the next one. So we're going to do first is count the significant figures. So, where do we start counting?
It's the 2, the first number.
Yeah, you can't start counting until way over here at the 2. Okay, so one of the rules said if there's a decimal point present, zeros can count. But remember, these ones can't count because we don't start counting until we get to our first non-zero number. So the 2 counts, none of the zeros before it do. The 1 counts, and the 5 counts because they're all not 0, right? So that's going to be 3. All that means is we want 3 in our answer. Now, to put it in scientific notation, we want our decimal point, so there's one non-zero number to the left. So what 2 numbers am I going to put it there?
Between the 0 and the 2. Well, the 2 and the 1.
Yeah, the 2 and
2 and the 1. Okay, that means choose a different color so that we're more clear. Yes, so we want it between the 2 and the 1. So what we're going to get is 2.15 times 10 to the something. And to figure out the something, we go to our decimal point, the original, and count how many times it takes to get it between the 2 and the 1. So 1, 2, 3, 4, 5. So it's going to be 5 times to get it there. Now this time, I moved my decimal point to the right.
So it's going to be negative.
It's going to be negative. Okay, so we're treating it like this negative sign's not there. We're doing it just like the positive ones. It's just at the end, make sure you go over and keep the negative sign. Okay? All right, so let's do one more. This time I have a scientific notation, and we're going to write it in normal, just to show a negative one in that light as well. So to figure out how to put it in normal notation, we're going to be using the exponent. The exponent's going to tell us how many times to move that decimal point, and the sign of it, whether it's positive or negative, will tell us what direction. So we know we're going to have to move it 3 times.
That's
So
right.
start at the decimal. In which direction?
Right.
To the
It's
right?
negative.
You want it to get bigger?
Oh, but that's in reverse, so it goes to the left.
Yes, it goes to the left this time. So
Yeah.
that's why it's kind of hard to remember this right-left
Yeah.
stuff, because it changes when you go the other direction.
Yeah.
That's why I like to think, oh, this number was greater than 1. This number was less than 1, so it's negative.
Yeah, it goes.
But it does get confusing to remember it that way when the negative signs are here.
Yeah.
So, but yes, we want it to get smaller, because that negative 3 is saying it's going to be a little small number. So 3 times to the left. And then we'll just put
Zeros.
zeros there. We're going to keep our negative sign, and it's going to be 0.0062. Is that correct?
No,
Why?
because we have 3, and we don't have 3 significant numbers over there, so we need another 0.
We need to keep this 0. If we would have counted the significant figures first, like we did in the first 2 examples, we would have noticed that this 0 does matter because there's a decimal point and we started counting at the 6. So 3 sig figs here. In order to have 3, we add a 0.
That's how I was checking my work by counting the significant figures.
Yes. And I like to count them at the beginning because once I start moving my decimal points around, it's unclear to me sometimes. Like, wait a minute, where was that decimal point originally?
I understand that completely. It was the conversions that I just
And
put
that's
my
what we're
pencil
going to
down.
do next. Yeah. So the conversions, I just wanted to review this a little bit since I hadn't done any negative signs, and I saw a lot of people in the discussion were having troubles with this type. So I wanted to do a short review with that, and then what we'll talk about next is the conversions. Especially because if you have lab this week, you're going to need to know how to do the conversions to finish the labs. And some of the lab conversions get pretty intense. So let's start. And it's best to watch the PowerPoint before you try working through some of these problems, just because it'll explain the why behind everything. But what I want to hand out to you guys.
Is that the one with the railroad track explanation?
Yes.
That still confuses me.
Well, it's going to until I show you several examples on board. That's
Okay.
just a given. So I'm going to hand out, and this is posted on Blackboard. There's actually a couple different ones. This one's just a kind of condensed version. That way you can kind of follow along and
Yes.
see where I'm getting the conversion factors from.
Yeah.
So these are English to metric and English to English type conversions. And then I'm going to talk about metric to metric at one point. And this is kind of a cheat sheet. This is going to be really helpful come exam time. Because for metric to metric, they don't give you conversion factors like that first sheet. They give you this weird table that you have to try to figure out what the conversion factor would look like. So this is deciphering the table for you. So if you go to the conversion factor sheet I handed out, and down at the bottom it says metric to metric prefix, that's where this extra table goes. It is deciphering that bottom half. Okay, So we'll use that once we get to metric to metric. All right. Now I have to get out my examples. So for conversions, basically what we're doing is we're just trying to go from one unit to another. Okay, in order to do that, we need conversion factors. You've done conversions probably millions of times in your life without even realizing it. Okay, if you're like, okay, how many seconds are in an hour? That's a conversion factor. You needed a conversion factor to figure that out. So we're taking it a step further and using several different types of conversions. So I'm just going to jump right in and show you an example. So if I had 0.50 inches and I wanted to know how many meters is that? All right, so inches, that's English system, right? That's what we use here in the US. So that's kind of how you can recognize if it's English or metric. Do we use it here? If the answer is yes, this is English. Meters, that's actually metric. Okay, so we're going from English to metric conversions. So whenever you're going from English to metric, you're using the top half of these conversion factor tables. Okay? And to help you narrow down which area to look in, look at what unit of measure we're using. In this case, inches and meters, that's a length, a distance. So you're going to look in the length area of the table to try to find some conversion factors that will help. So do we have a conversion factor that goes from inches to meters? No. I'm jumping right in. I'm doing a hard one. It's not even a one-stepper. Okay. So if you don't have one that goes directly from inches to meters, do you have one that goes from inches to something metric, whether it be millimeters or centimeters or kilometers?
We have one from centimeters to inches.
Centimeters to inches, that will work. So I'm going to write that conversion factor down. I'm going to write them off to the side here because we're going to use them in a minute. But it is 2.54 centimeters is equal to 1 inch, correct? Okay, so what that would do is it would get me from inches to centimeters. Okay, so from there, I can go from centimeters to meters. And that's going to be that metric to metric table at the bottom. Okay, so how do I figure out that conversion factor? You're going to get your cheat sheet. So on your cheat sheet, find a conversion factor, so separated by an equal sign that has centimeters and meters in it.
1 centimeter equals 10 meters.
Yes, so this is why we're learning scientific notation. We're going to be using it. So we're going to learn how to put that in our calculator today.
Oh, she's
And if you don't have your calculator, practice it at home. The video will be posted. So in this case, I needed 2 because I didn't have a conversion factor that went directly from what they gave me directly to what I wanted. So instead, I went from inches to somewhere in the metric area and then found a metric conversion to go between centimeters and meters. Okay, so how do I start? Well, obviously you start by finding conversion factors, but what's next? What's next is I do what I call railroad tracks. So it's basically a long line. You start like this. All right, so what's always going to go in this upper left-hand corner? Always going to be the question, the number they gave you in the question. That's how you're always going to start. So I'm going to start this top left-hand corner with 0.50 inches. And what's going to go next, right here, is one of my conversion factors. And it's going to be in a fraction form. So the reason that conversion factors are set apart with an equal sign is it can be represented in 2 ways. You can flip that. So what I mean is this first conversion factor can be written with the centimeters on top and the 1 inch on the bottom. So I'm just putting it in a fraction form. Or I can write it with the inch on the top and the centimeters on the bottom. Now, how do you know which representation is going to help you? Well, imagine picking these up and putting them in this space I just made. Now, to figure out which one you want to make sure that you're canceling out what you don't want and keeping what you do.
With the inch inch on the bottom.
We're going to want the inch on the bottom, yes. So we're going to pick this one, putting the 1 inch on the bottom. And the reason why is this horizontal line, that's a division line. So I'm taking inches and I'm dividing it by inches. So that means they're going to cancel. So by having it on the bottom, I can get rid of the inches. That means the 2.54 is going to go on the top. So if I stopped here, if I did 0.5 times 2.54 divided by 1, I would be in centimeters. Okay, but I don't want to stop because I need to get into meters. So that's why we have two conversion factors. So the second one here, we can do the same thing we did here. Okay, and I can even do it in a different color so we can see a little bit better. But write it in a fraction form. Try writing it with centimeters on top. Try writing it again with the meters on top. You don't have to do this every time, but it's kind of helpful at the beginning to be able to visualize it a little bit better. So now which one's going to help? Do we want meters down here in the denominator, or do we want the centimeter portion in the denominator?
Centimeters.
Centimeters. That's what we're trying to get rid of. So if we're trying to get rid of it, we want the 1 centimeter in the bottom, because this is the division sign. If they're on opposite sides of that horizontal line, they're going to cancel. That's going to put my meters on top, and that's good, because meters is what I want my answer in. So now, notice I've canceled out all units except meters. So when I enter this in my calculator, when I do this calculation, my answer will be in meters. So the next step is, how do I do the calculation? Okay, well, we said that this was a division line. Well, the vertical lines are multiplication, so you multiply across. Same in the bottom. Whatever in the bottom, you're going to multiply across. So I'm going to write it out just so you can see exactly what we're doing here. So we're going to have 0.5 times 2.54 times 10 to the negative second. And all that's in the numerator. And we're dividing it by, in this case, 1 times 1. So it's just 1. But I wanted to write it, sometimes it's not always going to be 1s in the denominator. So if you have your calculator here, you might want to try entering that and seeing if you get the same answer that I'm looking at here. That way if you have any troubles with entering scientific notation, I can help you out with that. So 0.5 times 2.54, EB, -2. So I get 0.0127. 0.0127. Okay. But notice, I'm not done. First off, I need to put a unit on there. Numbers are meaningless without units, so I want to make sure I'm including an M for meters. But also, we didn't learn sig figs just so we could do it for a day and forget about it. We also need to do it when we're doing our calculations. So going back to the original number,
We had 2 sig figs.
2 sig figs. So when you're figuring out sig figs for a conversion, only look at the original number given in the question. Okay? These conversion factors over here, they're called exact numbers. They don't count towards significant figures. So just the numbers in the question. There are 2, okay, because of the decimal, and we started counting at the 5. So when we come down here to our answer, we want just 2 significant figures in our answer. So what's going to be our first significant figure?
1.
1, yes, because you can't start counting at the 0. You have to be a non-zero number. So 1, 2, and then look to the number next to it. Round up if you need to. In this case, do we want to round up?
Yes.
So 0.013, and I'm going to put my units on it this time since it's my final answer.
Oh, this is so much better.
So 0.5 inches is equal to 0.013 meters. If you really want to, you can check that out in lab with our meter sticks. All right, I'm going to have another example on here. So just look at that for a minute, and I'll ask if there are any questions on it before we actually do this next problem. And a lot of conversions is just getting used to finding the conversion factors and knowing where to look for them. So really is just practicing. All right, were there questions on this one? Now that you have a second to process it. Started off with a tough one. I wonder if this one is a one-step one. So the next one, we're going from grams to ounces. So to figure out where to look on your conversion factor table, one thing, grams is metric, but ounces is not. Okay, so it's going to be this English to metric stuff. It's not going to be this big table here, right? Because this is only metric. Next, what are we measuring? We're measuring mass. Grams, ounces, that's a mass. So that's the area that would help you figure it out. So do we have a conversion factor that goes directly from grams to ounces?
Yeah.
Yes, so this is a one-stepper. This is the one I should have started with, right? So what is that, the 28? Is that the one you guys are looking at?
Mhm.
Okay. Grams. You can do one. So I'm going to write CF, that's my conversion factor. All right, so once you find your conversion factor, you start your row tracks. So draw it out. And what's going to go in this upper left-hand corner every time?
The original problem.
The original number, yes. So we're going to start with our 56.8 grams. Okay. Now we're going to take this conversion factor, and we need to figure out what part of it's going to go in the numerator and what part of it's going to go in the denominator. So do we want grams up top or down below?
At the bottom.
At the bottom?
Why? They need to cancel.
Because we need to cancel. So when you're trying to figure it out, just look, okay, I have grams, I don't want grams, that means I want grams in the bottom. They're on opposite sides of this horizontal line so that the gram portion can cancel. That's going to put the 1 ounce, so the rest of the equation here, on the top. So one step, now we need to solve. Okay, so how do we solve? Well, remember the vertical line was multiplication, and then this horizontal line is a division line. So we're taking 56.8, multiplying it by 1 in this case, and then dividing by 28.35. All right. And I get a really big number, but that's okay because once I use sig figs, I won't have to write. So there's more digits than even that, but I know I'm not going to actually need to keep more than that, so I'm going to stop there. I'm going to refer back, figure out how many sig figs I need in my answer. And remember, when we're looking at sig figs, we are not counting what's in the conversion factor. We're looking at just what was in the original number given in the problem. So how many sig figs in that guy?
3.
3. They're all not 0. Okay? Those are the easy ones, right? When there's no zeros involved, you don't have to think as hard about it. So 3 total, so we want 3 here. It's going to be 2.00, yes. So 1, 2, 3, you look at the number next to it, it is 4 or lower, so that stays a 0. So 2.00, and don't forget your units. We just went to ounces. Hey, they're so cool. I'm glad you're
I'm
most
just
people are excited about
struggling.
conversions. So I appreciate that, especially in the morning on a rainy day.
Oh, thank you.
But that is clicking. And if it's not clicking yet, do not worry, because it usually takes quite a few example problems before you start to get into a trend. All right, so let's keep on rolling. Let's try another one. 7.5. Let's do quarts. We go to milliliters. So I'm trying to explore all over the board. We did length, we did mass, now we're doing volume. So this is English to metric in this case. And so one way to tell that, by the way, is if it was metric to metric, it would have a letter in common. Okay, so for instance, it would be like 0.75 CL to ML. This would be metric to metric because they're both liters, LL. Okay, so the reason when I'm going through, I'm like, oh, that's English to metric, that's English to metric, because there's no letters in common, notice, right? Even on this one, no letters in common on both sides. So that will kind of help you figure out where to look for your conversion factor as well. And we'll do metric to metric in a little bit, but I want to start with these English to metric ones first. Anyone find a conversion factor while I was jabbering on? Do we have one going straight from quarts to milliliters?
We got
There's
one
quarts
from
to
quarts
liters.
liter.
There's quarts to liters. So very good. If you can't get directly where you need to go, get somewhere near it, right? So if I can get from quarts to liters, I'll be in the metric range, and I can use my metric to metric conversions at that point. So I'm going to write them over here. And you guys are looking at, well, there's actually two. Doesn't matter which one you use, right?
Yeah.
So 9, 4, 7. I'm going to just do this one because it was the top one. Okay. So if I use this conversion factor, I'll go from quarts to liters. So next, what I'm looking for is liters to milliliters. Okay. So for that, we're switching and going to our big giant horizontal table, looking for how many liters are in a milliliter. So you want to go all the way down. So if you look at this metric table, these are the prefixes. So you want to go down to where the milli is, M-I-L-L-I. You can follow it across. The first section's length, the second is mass, and then the third one's volume. So that's where you're going to see the liters. So it's going to be 1 milliliter, and then 10 to the negative third liters. All right. So find your conversion factors. Once you have them, start your railroad tracks. What's going to go in this upper left-hand corner? 0.75. And notice as I'm doing this, I'm always keeping the units as I go, so that it's going to help me know how to set up those conversion factors. So what conversion factor do I have to use first, the top or the bottom one? The top. It's the only one with quarts, and what am I trying to get rid of?
Quarts.
Quarts. So is the quarts going to go on the top or bottom?
Bottom.
Bottom. Okay, so quarts on the bottom, because then they're on opposite sides of that horizontal line. That's going to put my 0.947 liters on the top. Quarts are canceling. If I stopped here, I would be in liters. But I want to keep going. I want to get into milliliters. So that's what my next conversion factor is going to do. Do I want the liters on the top or the bottom?
Bottom.
Bottom. So that's going to be that 10 to the negative 3 part. Boom of thunder. And then the 1 mil will go on the top. Okay, opposite sides, the L's cancel. So once I do this calculation, the only units I have left are milliliters, and that's what I want. Okay, so how are we calculating this? This time we got lots of stuff going on. We're multiplying across, remember? So 0.947 times 1. Let's multiply all that in the numerator, and then in the denominator we have 1 times 10 to the negative third. Now, when you enter this in your calculator, especially what's in the denominator, most calculators need you to have it in parentheses because it's an exponent, okay? So if you're entering this and you're like, it's not working, I'm not getting that. Some calculators need it in parentheses, only when it's in the denominator for some reason. I'm not 100% sure why, but I know my calculator's like that. So I'm going to divide by 1. So I get 710.25. And if you want to, you can always convert that into normal notation. You know how to now, right? So you can just move that decimal point over 3 times to the left and check it that way. I mean, this is scientific notation. We know how to go back and forth with it now.
Right.
So if you need to, or even just to double check your answer, you can do that. All right, sig figs, huh? 2, yep, looking at the original number, so 1, 2. Oh, so this is gonna be a fun one around. I guess I'm doing the harder one on the board, right? So 7 counts, the 1 counts, and then I'm stopping there, because that's 2, right?
Mm-hmm.
But I'm not just gonna put 71 and be done with it. What do I need to put here?
A decimal?
Not a decimal.
So
So I went from 700 and something to 71. So I need a placeholder here that's not going to count as a significant figure so that I'm still in the 700 range.
0.
0. If I put the 0 there, as long as there's not a decimal point, it doesn't count towards sig figs, but I'm still in the 700 range. Okay? So that is the most common mistake, is when people have just 2 sig figs with a really large number, they tend to just write those 2 significant figures down and they're done. Okay? No, you need to make sure you're putting zeros for all the placeholders that you need so that you're still in the same range. Okay, so if this was 71,000, for instance, you'd add another 0, so on and so forth. Just make sure you don't go from 700 down to 70s. Okay, so this would be the correct answer, except for I need my units. And we are in milliliters. Now it's the correct answer. All right. Let's get harder now. Should we try metric to metric? We haven't done that yet. I mean, we've done one step of metric to metric, but not the whole way. So let's do this. I'm going to show you a shortcut way to do metric to metric during lab 3. For now, we're going to use it, do the tables. All right, so first of all, how do I know it's metric to metric?
The letter in common.
The letter in common, they both have L's. Okay, so that tells me that I'm just going to be using this cheat sheet, this big guy. All right, now notice, so we are doing liters, so we're talking volume. So you want to go to the liter side, that very last column in the metric to metric conversion factor table. And what you want is the centiliter, so centi, and the milli. Okay, so I know this is milliliters and not megaliters because it would be a big capital M if it was that megaliters on the top. Okay, it would be as big as the L, if not bigger, just to prove a point. So notice also, when you look at the metric to metric, it always goes to liters. So you have liters to liters. And when I see it's nanometers, that's supposed to be NL. I just found an error in that bottom one. It should say NL, not NN. Sorry about that. Must have carried it over from the meter part. So notice it always goes to liters. So what we're going to have to do is go from centiliters to liters. That's our only choice. And then from liters to milliliters. So it is going to be 2 steps, 2 conversion factors. So what are those conversion factors? 1 centiliter is equal to what?
10 to the negative 2.
10 to the negative 2 liters. And then we need the milli conversion factor as well. So 1 milliliter is equal to 10 to the negative third. All right, so this first conversion factor will get rid of centiliters. The second conversion factor will get rid of liters, and then we'll be left with milliliters. So do our railroad tracks. We have 2 conversion factors, so 2 steps. But where are we going to start? What number is going to start our railroad tracks? 65. Yes, thank you. 65 CL centiliters. So we have to use the top conversion factor first because we're trying to get rid of centiliters. So we're trying to get rid of it. Is it going to go on the top or the bottom? Bottom, yes. So the 1 CL will be on the bottom, putting this 10 to the negative 2 along the top. Opposite sides of the horizontal line, centiliters cancel. If I were to stop there, I'd be in liters, but that's what the second conversion factor is for. It's going to get me out of liters and into milliliters. So do I want the milliliter portion on the top or bottom?
Well, the top, because you want us to cancel.
Top, I want the milliliter portion on the
Yeah, on the
top,
top.
yes. Because that's what I want to keep. So you'll notice kind of a trend. Whatever you want to keep, you're going to end up putting on the top. Right? And then the 10 to the negative 3 liter portion right here is going to go on the bottom. Are you guys seeing this okay, or do you want me to write it in the fractions like I did at first? You know, where I wrote the 2 different ways.
I mean, I'm
Or is this
okay with
working
that.
okay? All right. Just let me know. Something's not clicking. So, multiply all the way across. 65 times 10 to the negative 2 times 1. And on the bottom, we have 1 times 10 to the negative 3.
In the parentheses.
In the parentheses, yes. Thank you for reminding me. When you enter in your calculator, put it in parentheses. Just to be safe. It's not going to hurt anything, right?
Yeah.
So, 65. I get 650. I'm running into the problem over here. So I got 650. I think that's what my calculator spit out. Is that the correct number of sig figs?
Yeah. The zero will count.
Right, the zero doesn't count. So to look at sig figs, we're going up to our original number that they gave to us in the problem, 2. And we want to keep 2 here. 1, 2. As long as there's no decimal point there, it is just 2. So now to end it, we just need to make sure we're putting our units. And it's milliliters in this case. All right, now I'm going to do one that I saw in the homework that I think is one of the harder ones in the homework. It's not the exact same numbers, but it is the same units. So let's look at, I have time for it, right? Yes, good. 8 pounds, 8 ounces. So this is going to help if you're going in the medical field. Say baby was delivered, it weighs 8 pounds, 8 ounces. And we want to know how many grams that is.
First of all, that's a big baby.
Wait. I think in the question on the homework it's only a 6-pounder, so that'll make you feel better.
Average.
Okay, well, the reason this one's a little more difficult is because we have 2 different units here, right? And we're trying to convert it to one common unit. So my first step that I'm going to do is I'm going to get this in all the same unit. And it's your choice. You can put it all in pounds, or you can put it all in ounces. I would prefer to put it in ounces, just so I'm not getting a decimal point. But it's your choice. Both ways will work, and you'll still get the same answer as long as you are canceling out what you don't want and keeping what you do and going through the process. Okay, so my first step is I'm going to take this 8 pounds. So I'm kind of breaking it up. And I'm going to get that into ounces first. So I need that conversion factor, I think you just said it. It's mass, right?
Yeah, I just know it's 16 pounds in it.
Oh, it's not even on here, is it?
I don't think so.
16 ounces in a pound.
Yeah, 16 ounces in a pound, so 16 pounds.
So this would be called a memorized conversion factor, because it's not on the table. And like I said, this table that I handed out to you, this is you have a huge, more inclusive one on your blackboard. So if you go into course content, it basically says everything you need for chapters 1 through 9. And it's much bigger, and it will have that conversion factor on it. I just didn't want to print off 5 pages for you
That's fair.
to go through. So 16 ounces in 1 pound. Okay. So let's just start. Let's figure out how many ounces are in 8 pounds. And this is something you might have done before in your head without even realizing that you're setting it up this way, right? So we want the 1 pound on the bottom and the 16 ounces on the top. So we're just multiplying. Anyone know what that is? 128. Okay. Now notice, I'm not going to look at sig figs right now, because this is not my final answer. I'm just going to keep all those digits. You only count sig figs when you're done and you're ready to report your answer. Otherwise, keep what you can. It's going to be a more accurate answer. So we have 128 ounces in 8 pounds. So how many ounces is that kid? How do we figure that out?
Add the other 8 ounces and they give you 136.
Right, so I'm going to take this other 8 ounces and I'm just going to add it. Because we want to know the total ounces of that kid so that we can go from ounces to grams. So 136. Everybody with me so far? Okay, so now I basically changed this, right? I'm now saying 136 ounces equals how many grams? I just put it all in a common units. So, go over here. We need a conversion factor yet again. This one we should have on our sheet. Going from ounces to grams.
28.35 grams to 1 ounce.
So the conversion factor. 8.5 grams to 1 ounce. All right, so do our railroad tracks again. Now what number am I starting with in my railroad tracks? 136.
Ounce.
Okay, so do I want the 1 or the 28 on the top? 28 on the top, yes. Because I want the grams on the top. That's what I'm trying to keep. And I'll put my ounces on the bottom so that they cancel. It's going to be a big number. 136 times 28.35. Of course, I erased my original number, so I can't even count sig figure at this point. That's me. All right, so I get that big number. You want to check sig figs. And before, it said 8.0 pounds, 8 ounces, right? So how many sig figs is in that?
And got 1, 2.
2. Well, it was,
And then the other one, do you add the other one and make it 3?
no. Because 8, so this is kind of confusing. So you had 8 pounds, 8 ounces, right? So it's going to be 2 sig figs. So the reason I'm not including this one is because this is part of the same number. They're just representing it in a weird way. So when you approach something like this, pick the number with the most sig figs and keep that. Because I know I say always the least, but in the case of when there's 2 different units, since these belong together, you don't want to add it and say there's 3, but if I were to convert all of this to pounds, there would be 2 sig figs, if that makes sense, if I went the other way.
And 2 different units.
So we want to keep just the 2. Okay. If I said just 8 ounces without the pound portion, then it would just be 1 sig fig. But so this is another one of those hard ones. I just want 2. So the 3 and the 8. Look to the number next to it. Is that going to stay an 8 or become a 9?
9.
9. Can I write 39 and be done with it?
No.
What do I need to add?
The grams, which is what we want to.
I need units, grams, but I went from 3,800 down to
Other
39.
placeholders.
Placeholders, how many?
We have 2 sig
2.
It's going to be 2 zeros. So the reason it's 2 is because I need to keep placeholders. Everything before that decimal point, I need a number there as a placeholder so that it's still in the 3,000 range. Okay, so those 5s are going to become zeros so that they're no longer significant, but also so that we're staying in the 3,000 range like we need to. That baby's 3,900 grams.
It sounds heavy, but it's really not.
Yeah, it sounds really heavy, but it's not. Maybe that's why we do pounds and ounces here. All right, questions on this one? So ones like these kind of get all over the place because you're trying to first get the same type of units, make sure you're adding so that you have all the ounces the original question was asking for, and then doing the conversion. So that's why I want to do one like this. I think that was probably the hardest conversion one on your homework. But let's try one more. We have a few minutes left. And on Wednesday, I'm going to continue with this, like doing problems, more conversion problems. Just because there's so many different types. I want you to be able to see a lot of them. one, you'll probably see something similar in lab. Whether you're taking lab in person or not, you're still doing the same assignments. So this one's different because notice the units are squared. So before we worried about the fact that they are squared, let's find a conversion factor. So where are we looking? English to metric or metric to metric?
Metric to metric.
Metric to metric, they have that letter in common, and we're going from what? Meters to centimeters? So find the centimeter portion, and is that 1 centimeter is equal to, I lost it, 10 to the negative 2. Thank you. Okay, so this is going to be the conversion factor we're using. Okay. I'm going to start the roto tracks, and then I'll show you what we're going to do with this squared part. So when I start my roto tracks, what number am I starting with? 3.6. All right, now notice if I take this conversion factor, right, I want to cancel out meters in this case. So I'm going to put meters on the bottom like we normally do. But that's only going to cancel out one of the two. So you can do this in two ways. You can square the entire conversion factor, or you can just write this twice. See what I'm doing here? It's both work. Okay, so I have meter and a meter, so that's two of them. So that cancels out the both of these. I also need it in centimeters squared, and when I times centimeter by centimeter, I get centimeter squared. Okay, so it's okay to write it this way. A lot of people too just prefer to square the conversion factor itself first. Okay, so whichever one works better for you, do that way. So if I were to square the conversion factor, you make sure that you are multiplying the numbers in front as well, squaring the numbers in front. So 1 squared would be just 1. 1 squared is 1. And then it's going to square the centimeters. And then 10 to the negative 2, you're going to have to square that number as well. Okay, so to square that number, you're taking 10 times negative 2 times 10 times negative 2. Okay, this will actually give you 10 to the negative 4. And you might need to put that in your calculator to verify it for yourself. But, so I could have just done a one-step problem and put this here, or I can take the same conversion factor and just write it twice in a row. Okay? I know this one's confusing. We're doing a cubed one actually during lab, so we'll get more practice with this. So to solve it, remember multiplying across. So 3.6 times 1 times 1, and then my bottom, I'm going to get 10 minus 2 times 10 to the negative 2. Actually, that's just 3.6 times 10 to the 4th, isn't it? That would change to a positive. And centimeters squared. And I'm running into my other problem. See, this is the thing about conversion problems that take up more than half the board. So once you do this division, this should be the answer you get. And you'll notice the nice thing about metric to metric is the number itself never actually changes. It's just where that decimal point is that does. Okay, so you'll either see this on your calculator or you'll see 1, 2, 3, 4. Did I do too many? No, that's 3 zeros, right? All I did was change this scientific into normal. Move that decimal point 4 times to the right. Okay. So depending on your calculator, what your functions are set at, it might show you the scientific notation form, or it might spit it out in normal notation. Okay. So on Wednesday, and I have room in my class Wednesdays if you guys want to come both days. I only have 4 people that are supposed to be showing up on Wednesday. I'm going to continue this. So we're going to kind of pick up where we left off and just keep doing conversions. So bring me any questions you have. If you don't have questions, I'll have tons of problems. What?
Do we need to sign up first or let you know how many is coming?
No, because I only have 4 people signed up for Wednesday,
Oh,
and I just checked. So, and I can fit, I think they said 11 in this room. Well, I have 5 people, but still, 6, 7, 8. So either way, we're good. So this is all I have for you today. Are you guys in lab on Monday?
Mhm.
In person too? Okay, so we're going to continue this kind of stuff during lab. We'll do some measurements and stuff as well.